Alright, this is week 5 math. This is pretty much all the same thing, but there's differentiation that's new. So I'm going to skip any old questions like this. So question 1 I'm going to skip. Okay, for this one here, pretty much it's differentiation. For differentiation, it basically means to derive. Now this is the rule you need to know. Okay, if they ask you to derive, okay, or differentiate, this is the rule. Okay, now here they gave you the rule, so you just follow what they're telling you to do. So limit as h approaches 0 minus g of h. G of h, and you substitute x by h. So you go 2 minus third root of h minus g of 0, and you substitute x by 0. So minus 2 plus 0. Because substituting x by 0, you get 0 under the root. Over h. And remember, this is the limit as h approaches 0 minus. Type this cancels with this, so you're going to be left with negative cube root of h over h. Akid, you have limit as h approaches 0 minus on the side. Type, what's this going to be? Ignore the negative for now. It's going to be, always write limit, huh? Ignore the negative for now. It's going to be cube root of h over h is going to be 1 over cube root of h squared. Why? Because this is 1 over 3. This is 1. 1 over 3 minus 1 is negative 2 over 3. Since it's negative, you take the power down. Okay? And the numerator goes as the power under the radical. The denominator goes as the power outside on the index. So you get this. Now, approaching 0 minus. So it's going to be negative 1 over cube root 0 minus squared. 0 minus squared becomes 0 plus. Because you're squaring, so it becomes positive. Cube root of 0 plus is just 0. So negative 1 over 0, which is negative infinity. That's that. Now for this one, it's the same exact steps. Then here, vertical tangent. You need to know, if you get negative infinity and negative infinity for both your left side and your right side, left side is minus, right side is plus, then vertical tangent. Tamam? Okay. Okay, part A and B, it's pretty self-explanatory. I won't explain because it's really easy. Okay, this is old stuff. You just substitute the numbers, and since the limit is equal to the value of the function, so therefore we can say it's continuous. This is the rule from chapter 1. I won't re-explain and do it again. Tamam? Anyways, part C, this is the new part. Okay, here they're giving you exactly what to do, so there's no reason to get it wrong. Okay, they want it at h plus 1. So, yeah, they want it at x equals 1. So which one do you choose from your piecewise function? You choose the first one. No, it's x less than or equal to 1. What do? You substitute f of h plus 1. So instead of always f of something, what goes under the brackets means change x by that. Okay? So here, f of h plus 1, and instead of x, you're going to put h plus 1. So it's going to be 4 into h plus 1 plus 6. Minus f of 1. Minus, what does f of 1 mean? Means substitute x by 1. So 4 times 1, 4, plus 6, 10. So minus 10. All over h. Okay, and don't forget this is the limit as h approaches 0 minus. Anyways, so you get what? You get 4h plus 4 plus 6 minus 10 over h. This cancels. You get 4h over, again, limit, huh? Limit as h approaches 0 minus. 4h over h, which is 4. Because h is cancelled, you get 4. So first one is 4. Second one, now they're saying 0 plus. So am I using this one now? No. Now I'm using the second one. 10x squared. Okay? 10x squared. Type. What do we do? Again, same process. f of h plus 1. That means substitute instead of x, h plus 1. So 10 h plus 1 squared minus f of 1 is what? Substitute 1. F of 1 is equal to 10, right? So minus 10 all over h. And again, you have the limit over here. Simplifying this top one will get you 10 h squared plus 2h plus 1 minus 10 all over h. This is going to cancel with the 10 times 1. You're going to get 10h squared plus 20h over here. 10h squared plus 20h over h. You can cancel. If you factor out the h up, you get 10h plus 20 all over h. Cancel, because I factored, huh? cancel, you're gonna get limit as h approaches 0 plus of 10h plus 20. Substitute now your limit, so you get 0 plus 20, which is 20. That's why the answer here is 20. Then the last one here, the 9991, this is now saying h approaches 0. To get h approaches 0, same thing as how the limit used to be. That means the limit as it approaches 0 minus must be equal to the limit as it approaches 0 plus. Are they equal? No. So does it exist? No. Type. So what does that mean? Is it differentiable or is it not differentiable? It's not differentiable. Why? Because these two are supposed to be equal, the 4 and the 20, but they're not equal. Tamam. This is continuity. This is old. Again, just substitute your values and you're gonna get it correct. Then how do you know if it's continuous? All these 4 must be equal for it to be continuous. Okay, consider the function. Again, piecewise. They want you to know the limit, right? Continuous, whatever. How do you find the limit? مثلا of 0 minus. What do you substitute 0 in? The first one or the second one? Obviously the first one. So it'll be 2 times 0 plus 1. Okay, which is 1. They said that it's equal to f of 0. Okay, what's f of 0? Yani substitute the x with 0. Now where do I do it? I do it in the first one or the second one? The second one. Because that means here x is equal to 0. And x is equal to 0 only in the second one. Because you see it's greater than or equal. Okay, so 0 plus 2, which is 2. Are they equal? No. This is how you do it. The rest is pretty self-explanatory. Okay, خلاص. This stuff, it's all old stuff. I'm not gonna repeat. Alright, this came in the periodic and many people did bad last week. Which of the following is true? H is not continuous at x equals negative 1 because its limit does not exist. At x equals negative 1, the limit exists since, look, left and right are both approaching the same value. Sure, they may be an open circle, but an open circle doesn't mean that the limit does not exist. Okay? For the limit to exist, only one condition must be satisfied, and that's the left-hand side limit is equal to the right-hand side limit. In this case, it is satisfied. فخلاص. It should exist, so this is wrong. H is not continuous at x equals 2 because it is not defined there. At x equals 2, look, there's no other shaded circle, so it's not defined. H is continuous at x equals negative 2. Over here, negative 2. Why would it not be continuous? Obviously, it's continuous. There's nothing to worry about. Okay? Easy. H is continuous at x equals negative 1. Negative 1, is it continuous? The second you see a hole, yeah, it's not continuous. H is not continuous at negative 1 because it's not defined there. Bella, it is defined there. Look, there's a shaded circle above, so it is defined. Okay, so this is now new. When you talk about differentiation, you need to know for a function to be differentiable, two cases. First case must be continuous. Second case, left differential must be equal to right differential. Now this is a pain in the ass because this takes time. Okay, this takes time. So preferably, to check whether a function is differentiable or not, check if it's continuous. Alright? So f is not differentiable, f is not continuous but differentiable. I don't care. This, by the way, is never true. You can never say that something is not continuous but differentiable. Never. For something to be differentiable, it has to be continuous. Anyways, so when you see a question like this, what do? The first step is check for continuity. Okay? Must be continuous. Let's check. On the left, substitute 0, you get 4 times 0 plus 1, which is 1. On the right, you get 3 times 0, which is 0. Are they equal? No. So is it continuous? Not continuous. So what do you choose? It's not differentiable because it's not continuous. Not differentiable because it's not continuous. Is it differentiable? No way. This limit of f of h minus f of 0 over h does not exist. What's this? What's this? Isn't this the rule? I told you this is the rule for differentiation. It doesn't exist if the function cannot be differentiated. Isn't it f of x plus h minus f of x over h? In this case, what's the x value I'm using? 0. But that's why I said f of h, because 0 plus h is just h. Okay? So obviously this will not exist, because the differential does not exist. Type, let's take a look at this one. Is the only one I didn't talk about. F is not differentiable at x equals 0 because f of 0 does not exist. Who said? Austin, did I say this? Did I write it down here? Did I say it does not exist? F of 0 or f of x does not exist? No. These are your two cases. Here again, we're talking about differentiation, whatever is differentiable, whatever. The first thing you check is it continuous? Okay? That's the first thing you check if you want to check for differentiation. Is it continuous? The first one, 2 times 0 plus 1 is 1, and then 0 squared plus 1 is 1. So it's continuous. Cool. طيب. Does that mean it's differentiable directly? No. I told you there's two cases. Cases that must be satisfied. First thing is that it's continuous. Second thing is that the left differential is equal to the right differential. How do you check the left differential and the right differential? This is where the rule comes in. Limit for the left side. Okay? What's the rule? H approaches 0, f of x plus h minus f of x over h. Type. Since we're looking at the left side, this is going to be 0 minus. So which one am I going to use? This one here or this one here? The first one, because we're looking at the left. So it's going to be limit as h approaches 0 minus f of, what's my x here? 0 plus h. H is always a letter. It's not supposed to be changed. It's always just going to be h. Minus f of, again, what's my x? 0. We put it here 0. So okay, of course it's going to be 0 over h. Then you continue. F of 0 plus h. So you're substituting it into this one here. So instead of x, what am I going to put? 0 plus h. So instead of 0 plus h, I just say h. So instead of x, I'm going to change it to what? H. So it's going to be, instead of 2x plus 1, it's going to be 2h plus 1. So it's going to limit 2h plus 1 minus f of 0. So instead of x, what do you put? 0. So 2 times 0 plus 1, which is 1. So 2h plus 1 minus 1 over h. These cancel, and you get 2 for your left hand derivative. Now we have to check what side? Right side. Yalla. Right side. Same exact rule. But now it's 0 plus minus f of x over h. What do? Same thing. But instead of substituting 0 into the first one, since we're looking at the right side, we have to substitute it into the second one. So, same thing again. This is the first step. You write it down like this. Second step, you change what's under these brackets. Change it. What's x are we substituting? We're substituting 0. So you just write this step by step. 0 plus h minus f of 0 over h. Type. F of 0 plus h is the same thing f of h. So substitute instead of x, what are we going to put now? H. So let's put negative h squared plus 1. So it's going to be limit as h approaches 0 plus of negative h squared plus 1 minus f of 0. Substitute f of 0. F of 0 doesn't mean you substitute here. No. F of 0 doesn't depend on the plus or the minus. It depends on the function. Where is the function 0? The function is 0 in the first one because this is less than or equal to 0, right? So when you want to substitute 0, here it doesn't matter because you're going to get 1 for both. But I've solved so many questions where it's different. Okay, so you need to make sure you know where you're substituting the 0. The 0 doesn't change. It's independent. It only depends on the inequality here. So I'm going to substitute 0 into the first one. Here, it's the same thing. Only for this question. But in other questions, it's all different. So negative h squared plus 1 minus f of 0 over h. Cancel. H squared over h becomes negative h. Change it. Now can you apply the limit? Yes. So limit as h approaches 0 of negative h is negative 0. Which is just 0. Type. In the left we got 2. In the right we got 0. Does that mean the left and right are equal? No. If the left and right are not equal, what does it mean? Is it differentiable or no? No. So does this limit exist? H approaches 0? No. Do we say it's differentiable? No. What? This is correct. Sorry. Do we say it's differentiable? No. Why is it not differentiable? Because the right and left differential are not the same. Type. Limit as x approaches 0 does not exist. This is something completely different. We're saying limit as h approaches 0 does not exist. So please don't mix up and choose this one by accident. Don't. Okay. Make sure you know what you're choosing. Then f of 0 exists. How do you know f of 0 exists? Obviously it exists. Here, x less than or equal to 0. So it's included in the domain. So how would it not exist? F of 0 exists, obviously. This one here, it's old. I'm not going to repeat it. It's old from last week, come on. Question 10. Oh, this is the intermediate value of theorem. Yeah, let me see. Okay, it's not IVT, but this is very easy. Okay, they're saying no, they're talking about continuity. Alright, about 2 secant x. Secant is 1 over cos. Okay, so it's gonna be 2 over cos x. تمام؟ طيب 2 over cos x, it's the quotient of two continuous functions. Someone's gonna tell me, bro, what do you mean? The numerator is 2. How is that a function? Bella, of course it's a function. F of x equals 2. It's just a horizontal line at x equals 2. طيب, what's wrong with that? Isn't that continuous? Yes, it is. So 2 over cosine x. Cosine x, I told you all trigonometric functions are continuous. So it is expressed as the quotient of two continuous functions. طيب, when will this quotient be continuous? I told you quotients are always continuous up until the point where the denominator equals 0. So that's why the second answer is correct. G is continuous up until it contains no roots of cos x, because cos x is the denominator. Can you say it's continuous on R? No, it's continuous on R because you have a denominator. That means there will be some values where it's not continuous. G is continuous at each of these points, pi over 2 and k pi over 2. This obviously is going to be wrong because pi over 2 will get you 0 as your denominator. Try cosine pi over 2, you get 0. So that's why 2 over 0 will be not continuous because it's going to be equal to infinity at that point. G is continuous at k pi over 2. Again, you can't have anything pi over 2. It will be wrong because the denominator will equal 0. G is continuous on any open interval that contains no roots of sine x. شو خص sine? We're talking about cos. So that's that. Alright, so this is a bit of intervals, but we're going to do them really quickly. G is left continuous at x equals 1. Let's take a look at x equals 1. Is it left continuous? Left continuous, yani, is it following a value? Yes, it is. Left continuous, it reaches 2. Alright. G is right continuous at x equals 1. Is it? Look at 1. Go to the right. It's approaching a value, but at that value there's an open circle. Is it possible to say it's right continuous? No way. How? Keef. G is continuous at x equals 1. Again, no way. Because it's left continuous but not right continuous. So how can it be fully continuous? No way. G is continuous on negative 3, 1. Using parentheses means excluding that x value. So from negative 3 till 1. But excluding the 1 and the negative 3. So everything in between. How do you know excluding? Because they use parentheses instead of square brackets. Square bracket means include. Type negative 3, 1. This interval here, everything in between. Do you see any holes, any jumps, anything? No. So that means it's continuous. G is continuous on 1, 3. Give 1, 3 from 1 till 3. That would be correct. But what's the problem? Is they put square brackets. So they're saying including 1. So including 1 means you're going to have to include this shitty circle, the undefined one. So, could that mean you're continuous? No way. Okay? Alright, which of the following statements is true? So easy. Okay, all you have to do is go step by step. Let's check. G is left continuous at x equals 0. At x equals 0, what's the value? What's the limit? 0 plus 5, 5. So what does it need to be left continuous? It needs limit as x approaches 0 minus equal to f of 0. This is what needs to be continuous. Type anyways. So it's left continuous at x equals 0. What does that mean? That means the left limit, which we got is 5, should be equal to f of 0. What's f of 0? X plus 5. Sorry, f of 0 is what? 0 plus 5, which is 5. As you can see, they're equal, so it's left continuous. Part B, G is continuous at x equals 3. How do you know it's continuous at x equals 3? To check that, you literally just check the bounds. 3 minus 5, negative 2. 2 times 3 minus 8 is also negative 2. See how they're equal? Exactly. For them to say it's continuous on negative 3, 0, that means everything here, what's the function? Like, this one takes a bit of thinking, okay? The function here goes from 0 till 3. To say that it's continuous from negative 3, 0, that means everything before 0 from negative 3 gets you a continuous function. How is this true 100%? It's going to be true 100%. لأنه before 0, everything to the left of 0 is the function x plus 5. There's nothing changing. It's just one function. So obviously it's going to be continuous on that interval up until 0. But after 0, that's when you start getting a bit sussy. A bit, maybe, suspicious. Is it going to stay the same? Why? Because now you're changing into a different function. So how I always think about it is as long as there's no change of the function, it will always be continuous. So from negative 3 up until 0, it's going to be continuous. G is continuous on 0, 3. this will be wrong. ليش؟ لأنه it's either discontinuous at 0 or discontinuous at 3. How do we check it? Let's check. Okay. 0 here will get me 5. 0 here will get me -5. You just found it. At 0, it's not continuous. For no way, this is correct. G is right continuous at x equals 0. At x equals 0. G is right continuous. No way it's going to be a right continuous. ليش no way? Because as we just did now, here you get 5, here you get -5. So to the right of 0, you're going to jump from 5 down to -5. Is that continuous? No. G is continuous at x equals 0. Again, no way it's continuous. I just showed you why. Here you get 5, you get -5. Alright. Here, before I do anything, I'm going to explain this one here by the intermediate value theorem. Basically, the intermediate value theorem states that between two x coordinates, if here you get a positive answer and here you get a negative answer, then there exists some sort, at least one root between these two numbers. Why? Because you're going from positive to negative. Type. So let's take a look at this. Substituting 1 will get you 1 minus 4, which is -3. Substituting 4 will get you 2 minus 4. Will get you, sorry. Substituting 4 will get you 16 minus 4 root 4, so minus 8, so 8. So you went from a -3 to 8. You went from negative to positive. Doesn't that mean there exists a root between them? Yes. So this is why by the intermediate value theorem, whatever. Then they're saying the function is continuous, not continuous. Always assume, here's how and I like to solve, is I always assume something is continuous until I see a denominator, until I see something undefined. So for now, it's continuous. So this should be correct. How do you check if it's not continuous? أول شيء you check for a denominator. تاني شيء you check for a radical. Because a radical means that the number here has to be greater than or equal to 0. So that means -4 root x must be greater than or equal to 0. So it's nice and easy, man. Get rid of the 4. You're going to get that root x is greater than or equal to 0. So basically x has to be bigger than or equal to 0. So this is your domain because of the radical. You need to just make sure that it's not negative. So obviously between 1 and 4 it's going to be continuous. Other than that, is there any denominator? No. So there's nothing to check for. So it's always going to be continuous. So this is wrong. The function g has different signs at 1 and 4. We just checked that earlier. Remember, I got you -3 and 8. Those are different signs. IVT, I told you how. The given equation has no solution. Why would it be no solution? We just figured out that there is a root, so that means there is a solution. Alright, when you say there's a root, that means there's a solution. Alright, that's what it means. Alright, so this one here, they want you to look at the differentiability. So obviously you need to look at the left and right differential. And they gave you the rules here, you just have to check whether they're true or not. Alright, so let's take a look. Over here, g of h minus g of 0 over h. So what do? We write limit as h approaches 0 plus of g of h. That means instead of x, what would I put? H. So 2 times h, absolute value h, plus 1 over 2, minus g of 0 now. Substitute g of 0, that means instead of x, what do you put? 0. So what are you just going to get? Half. All over h. I'm just copying the formula they wrote for me. Anyways, half will half cancel. 2h times h gets you h squared. So you get 2h squared divided by h. Remember, there's limit here. H cancel, you get 2h. Now substituting the limit, you're gonna get 0. Second one, same exact thing. Same exact thing. You're gonna get same numbers, same process, same thing, you're gonna get 0. Part C, g is not differentiable at x equals 0. We just found that the left and right differentials are both equal to 0. So how come it's not differentiable? No way. Alright, so this is wrong. This is completely wrong. The limit does not exist. Limit does not exist, that's when you get infinity. Do we get any infinity? No, we got zeros. We got zeros. Type g prime of x equals 0 at x equals 0. It took me a second to understand what this means, but g prime means what? The derivative. صح? And they're saying derivative equals 0. Didn't we find the derivative equal to 0? Yes. At what x value? 0. When you want to look at the x value, don't look at the thing h is approaching. You look at the thing here under the brackets. Alright? Because h is approaching 0 no matter what. No matter if you're looking at x value 9,999. It doesn't matter. you look for the x value, you look over here under the g. تمام. So that's this one, part E. Okay. Last one, g prime of x is equal to negative half at x equals 0. No, اتفقنا at x equals 0 the g prime is 0. Alright, for this one again I'm gonna skip because it's just continuity. It's very easy. This is all old stuff. Everything continuity is old. No need to do it. Okay, 16. Okay, given g of x and they want you to find the derivative by the definition of the derivative. Okay, here this is the first principle method, okay, or they say definition of derivative. How do you do it? It's very easy. The derivative is always equal to limit. I gave the rule already. H approaches 0, f of x plus h minus f of x over h. Alright, so let's do it. What's f of x plus h? This is what I do. I piece them up one by one, and then at the end, after I get everything, I put them all together. F of x plus h is what? Instead of x, what do you put? X plus h. So 2 plus x plus h squared. Tamam? So it's going to be 2 plus x squared plus 2xh plus h squared. Tamam. What's f of x? F of x is easy. It's what's given here. So 2 plus x squared. It doesn't matter if I use f or g or whatever. They're عادي bro. Okay, so now I have f of x plus h. I have f of x. I can just substitute everything back in. So it's going to be limit as h approaches 0. F of x plus h. So it's 2 plus x squared plus 2xh plus h squared minus f of x, which is what? 2 plus x squared. 2 plus x squared all over h. Cancel, 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 cancel. You get this. Limit as h approaches 0, 2xh plus h squared over h. Can't we factor all the h's and cancel them? Yes, we can. If you're 12s, you don't have to cancel like this. There's a huge problem. Okay, so you're gonna get 2x plus h. Now, substitute your limit. Instead of h, we put what? 0. So you get 2x plus 0, which is 2x. So your answer is 2x. Type, you're gonna tell me, what do you do? How do you get that from here? Basically, here, they're asking you, during your steps, what did you get? Is it this correct? Yes. Someone's gonna tell me, what happened to the 2 plus? Now they cancelled out. Okay, we don't care. This, did we get it? Wasn't it our last step? Yes. Did we get 2 plus on one side and on the other side there's no 2? No. Type, did we get x plus h? No, we never said x plus h. We said it's x minus h, right? Always show x minus h, sorry. لا, sorry, لخبطت. This is wrong actually because it's x minus h. Here is what I meant to say. I mixed these two up. This is wrong لأنه it's minus h. It's supposed to be what? X plus h. Okay? Here, why is it wrong? It's x plus h, but because they have the 2 here. It has to be 2 on both sides or no 2 at all. Okay? Here, did we ever get to 4? No. Here, did we ever see 4x? No. Type. Then they said g prime of 4. What does it mean? Just substitute what? 4. So 2 times 4 equals 8. Tamam? Easy peasy. Okay. Again, same thing by the definition of the derivative. So what's the rule? F of x plus h minus f of x over h, right? And obviously limit as h approaches 0. Tamam? Yeah, let's do it. Like I told you, find f of x plus h and f of x separate. Okay, so then you can just substitute them. F of x plus h, and instead of x, you put what? X plus h. So it's going to be 3 over x plus h squared. Let's simplify that a bit. It's going to be 3 over x squared plus 2x, 2xh plus h squared. Alright, f of x is what? 3 over x squared. Type, f of x plus h minus f of x, so it's going to be, let's write it, limit as h approaches 0, f of x plus h, so 3 over this mumbo jumbo, minus f of x, which is what? 3 over x squared, all over h. Okay, here you have two fractions that you're subtracting. So obviously you can't subtract two fractions if they don't have the same denominator. So we're going to multiply by the common denominator. This needs an x squared. This one here needs what? X squared plus 2xh plus h squared. For a second now, let's only look at the numerator and forget about this h for now. Because let's get rid of this fraction shit. So 3x squared minus 3 into x squared again minus 6xh. I'm distributing the minus 3 now. Minus 3h squared all over, what's the denominator? X squared plus 2xh plus h squared. And then all of this habal over h. Alright, let's do some nice stuff and like cancel and stuff. Okay, if we got that cancelled, you're gonna get minus 6h, sorry, minus 6sh minus 3h squared over x squared plus 2xh plus h squared. All of this over h. We can cancel this by this. Or no, can we? Hold up. Oh, this was divided by this. Yeah, of course you can. Because you're having this fraction here divided by this. So you can 6xh minus 3h squared. Factor out the h. It's going to be h minus 6x minus 3h. You can now cancel the h with h. So this is going to turn to minus 6x minus 3h. All over x squared plus 2xh plus h squared. Tamam? Okay. Now, what do? We limit it, right? So this is the first thing that's correct. Minus outside, 6x plus 3h. Someone's going to tell me, oh, it's plus instead of minus. Many, they took the minus out. That's why it became plus. So this first answer is correct. So what do you do in this stage? In this stage, honestly, yeah. So you get this here. Is there anything else you can further simplify? Nothing you can further simplify here. Literally nothing. You can't do anything. What are you going to add? What are you going to subtract? So when you can't simplify no more, h goes in. So it's going to be minus 6x minus 0, because h is 0, over x squared into x squared plus 0 plus 0. Tamam. Simplify this, you're going to get minus 6x over x to the power 4. So you're going to get minus 6 over x cubed. So this is your derivative. Tamam? That's your derivative. طيب. f prime of negative 1, so you substitute negative 1 here. So minus 6 over negative 1 equals 6. Over here, they want you to choose which is true. One is f of x not defined. It's a fraction. It's not defined, obviously, when the denominator equals 0. So when does x squared equal 0? When x is equal to 0. So this is true. F prime of x is not defined. What do we get as f prime of x? This over here. How do we know when it's not defined? Isn't it a fraction? Yes. And we know fractions can't be equal to 0. So x cubed cannot be equal to 0, which means x is not equal to 0. So these two are correct. They're defined for any real value? No, any real value, because it has a denominator. That means there's an asymptote. F is not defined when x equals 0, x equals 3. If you want, try it and check, but why would that be the case? No way. F is not defined, f of prime of x is not defined when x equals 0, x equals 3. Again, there's nothing that supports it. If you want to check it, you can just substitute 0 and 3 into here and check. Are they both satisfied? If only one of them is undefined and the other is defined, then you still can't choose this. You just can't. F prime of x is defined for any x? No way, because it's negative 6 over x cubed. Right, there's a denominator, so no way. Alright, this is gonna come. I'm 99% sure this is gonna come, but instead of x plus 1, she's gonna put something else, x plus 3 or x minus 4. But my absolute value, I'm 99% sure you're gonna see it tomorrow. So what's my point? Here is my point. What do you do when you see this? Again, they want us to do limit h approaches 0 plus, h approaches 0 minus, whatever. Okay, how do you do it? So easy. Really so easy. When you substitute 0 plus, when you substitute 0 minus, you need to check. You don't just substitute it blindly like this. This is absolute value. So how you do it is you split it into two functions, x plus 1 and negative x plus 1. Tamam? X plus 1 is for x. Sorry, other way around. You start with the negative 1, and then after it is the positive. It doesn't really matter, but no, hey, I do it. I like doing this. This is for x less than 1. This is for x greater than or equal to 1. Negative 1, sorry. Tamam. So when I want to say 0 plus, which one do I substitute it into? You have to substitute it into x plus 1. So when I say 0 minus, if you don't follow the step, you're going to choose this one in the exam and you're going to get it wrong. When I say 0 minus, I substitute it into the negative 1. So when you see this in the exam, what's the first step you do? You write this. Okay? The first one you just make it negative, second one you make it positive. تمام. How do you know if it's less than -1, greater than or equal to -1, whatever? It's from the vertex here. If it's 1, then you put -1. Okay, if it's 2, you put -2. It doesn't matter, but that's the point. Okay, so what do we do? Limit as h approaches 0 plus. They wrote everything down for you, so you just copy it. G of -1 plus h. What's g of x? In this case, it's negative. What we're doing 0 plus, so we're not going to do the first one. We're going to use the second one. So it's going to be, instead of x, what am I putting? -1 plus h. So -1 plus h plus 1. Cancel, cancel. So that means g of -1 plus h is equal to h. Like I told you, you find them one by one and then substitute everything. Then they want what? G of -1. Which one do you substitute g of -1 into? Second one, always second one. -1 plus 1 is 0. Tamam. So now we know everything, so let's go back to the limit. It's going to be limit h approaches 0 plus h minus 0 over h. And what's this? H over h is just what? 1. So what's the first step? Always for differentiation questions is to find them one by one, and then at the end substitute everything back into the limit. Okay? So this one's correct. This one, what many people do is they're going to substitute into x plus 1 again, and they're going to get it wrong. Why? Because they forgot that Walid told them if it's absolute value, you have to split it into 2 separate functions, the same way I did here. One function stays as is. The first function, you must make it negative. Tamam? If you do that, you won't get 1. You're going to get a different answer. Let's try it. Okay? G of -1 plus h. I'm now talking about what? 0 minus. Tamam? 0 minus. So which one do I use? The one up or the one down? The one up. So it's going to be negative. -1 plus h. So instead of x, I put -1 plus h plus 1. Cancel, cancel. You're going to get negative h. Then g of -1. G of -1, I told you, when you say f of 0, f of 2, g of -1, g of -2, it doesn't matter which, it doesn't change. It's always the same value. It's always in the same function. Where's the g of -1? It's in the second one. Why second, not first? Sometimes they say, aren't you doing 0 minus? Shouldn't it be in the first? No. G of -1, f of -1, f of 2, f of 5, anything. G of something, when it's just a number under the bracket, you have to look at where that number is. In this case, it's greater than or equal to -1, so you're going to choose the second one. Okay? And you get -1 plus 1 is what? 0. Now, did we find everything? Yes. So you can go back here. G of -1 plus h, which is negative h. Minus g of -1. So minus g of -1, which is 0. All over h. Limit. What do you get? -1. Is it 1? No, you get -1. That's why it's wrong. Tamam? Obviously, 0 plus and 0 minus are not equal. So does it exist? No, it does not exist. If the left and right do not are not the same, so is it differentiable? Absolutely not. Okay? Here they said the limit is equal to 1. We said it does not exist. So how can you say it's equal to 1? We said the derivative equals 1 at x equals -1. Now, these two are wrong. Why? This is where I'm going to teach you a new concept called corner point. Corner point is when you have the derivative on the left, we said it's equal to 1. Sorry, on the right, it's 1. Derivative of the left is -1. When you have these two are opposites of each other, then this is called a corner point. And that means, does this derivative exist? No. How do you know? Okay, instead of a corner point. مجرد ما we said that the limit does not exist for this h wrong rule, that means, what's this rule? This is the rule to find derivative. If the limit to find the derivative does not exist, then is there a derivative? No. So can we say g prime of x, I don't know what? No! No way. Okay? That's why. Alright, this one here, at which value of x is it discontinuous? Really quickly, just substitute at the bounds. Here, you're going to get 2. 1 here, you're going to get 2. 2 here, you're going to get 4. 2 here, you're going to get 4. 3 here, you're going to get 3. And then 3 here, you're going to get 6. Type 2, 2, 4, 4, 3, 6. As you can see, they're not equal. At what x value was that? At x equals 3. So that means the answer is 3. Alright, at what value of this is it differentiable to x equals 2? Every time you get a question like this, they're basically asking you, check if it's continuous. When is it, in other words, continuous? Okay, that's the first condition. So, check. x squared plus bx minus 2. Okay, for it to be continuous, that means substituting x here should give you the same answer as substituting x here, right? So that means 2 squared plus 2b minus 2 should be equal to 2 minus 6. Okay, so 2 squared, which is 4, plus 2b minus 2 equals negative 4. You're gonna get 4 minus 2 is what? 2 plus 2b equals negative 4. So you get 2b equals negative 6. So b is equal to negative 3. Is that clear? So literally all you have to do is just equate both sides, okay? And you get b is negative 3. It's kind of like those k questions we used to get. This you'll definitely see tomorrow, 100%. Okay, I'll place my bets on it. Okay, this one here, sine 12x over 3x, and then b to make it continuous. Obviously the limits have to be equal. This is the rule. It's sine ax over bx is just 12 over 3, which is 4. And so b has to be equal to 4. Question 22. This one, again, very easy. You just have to check what this limit is equal to at x equals 6, right? Substituting 6 squared minus 36 over 6 minus 6 will get you 0 over 0. So you have so many different ways to do this. You can factor. So it's going to be x minus 6, x plus 6 over x minus 6. Cancel, cancel. You're going to get x plus 6, so 6 plus 6, which is 12. Correct. Or you can use L'Hopital and derive. So you're going to get 2x over 1, so 2 times 6, which is 12. Alright, that's it for this video, guys. Thank you so much for watching, and good luck in your exam.